సార్ నేను అమ్మట కూడా అంటే లేదు లేదు సార్ ఫస్ట్ సార్తో మాట్లాడి మళ్ళీ ఇంకోసారి మాట్లాడతాను అండి.
Yeah, I will request everyone to mute yourself.
పోతాది కదా అన్నట్లు మాట్లాడలేదు సార్.
Jharkand sir.
I request all the participants to kindly mute yourself.
Can you
Please
tell
mute yourself.
Janappa sir? Yeah, now muted.
Yes, ma'am. As I said, I'll give you one example of temperature sensor. So temperature sensor is used to measure very low temperature also, like in minus. How much is the temperature? It can measure room temperature, it can measure body temperature. Again, if we are going towards the industry application, there the temperature range is around starting from maybe 100 degree to 1000 degree, 2000 degree, 2500 degrees centigrades are there. If we talk about steel industry, there the molten steel will have the temperature which is above 1700 to 1800 degree centigrade. So there also we are going to make use of a sensor. So we can see the application of sensors starting from our home in terms of thermometer. Then if you are measuring the ambient temperature, room temperature, there also we are using thermometer. But when we are going towards the application area where we are going to measure very high temperature, there we are using RTD, that is resistance temperature detector. Or if we are going to measure the very high temperature above 1000 degrees centigrade, above 1700, 1800 degrees centigrade, then we are going to use thermocouples. So thermocouples, it is working on the principle of Peltier and Seebeck effect, where there are two dissimilar metals are placed in two different temperatures. So one end will be placed in cold, it is called as cold junction. The other one is called as hot junction, and both the junctions will be placed at different temperatures. And when we are placing these two dissimilar metal at joining together and placing at different temperatures, then there will be flow of current in the circuit. That is the basic principle we are using in thermocouple. Now, when we are talking about very high temperature, like above 2200 degrees centigrade, there we are using optical sensors, optical pyrometers to measure the temperature. So we can just imagine or see like how the temperature sensors have varied applications. It is of different types. It uses different principles to operate. Also, it can measure the temperature which is ranging from minus 30-40 degrees centigrade up to 2500 degrees centigrade or beyond. So that is the beauty of this particular device, which is being used for measurement purpose. So you can see there are different types of sensors given here, that is color sensor, gas sensor, light dependent resistor, proximity sensor, IR receiver, ultrasonic sensor, humidity sensors. We are going to discuss each. I'm going to give the glance of each types of sensors, how we are going to, while discussing the different types of sensors. So now the sensors are mainly, it is interfacing with the real world. So how we are going to interact if there is a temperature change in the atmosphere, how we are going to measure that. So there is suppose thermometer is there, there is a bulb connected to which is going to sense the change in the parameter, sense the change in temperature, and it is going to give us the output. So we can see here there are three terminology given, that is transducer, sensor, and actuator. So this is the sensor part, is the part where or which comes into the contact of the parameter, or if it comes in the contact of the physical change in the atmosphere, whether it is temperature, pressure, humidity, or maybe any other kind of parameter, that will be sensed with the help of sensor. Now the role of transducer is that it converts the output of sensor into different form. Now if I have seen the temperature or measuring the temperature using thermometer, so thermometer is giving me the reading in terms of nowadays there are different types of thermometers, but when we talk about basic mercury thermometer will give you the expansion of mercury in the scale, which we have to read. That is analog kind of thermometer. But when we are, there are different thermometer. In fact, post COVID, everybody is using digital thermometer or IR thermometer. So again, digital thermometer, it will give you the digital output, but again you have to place the sensor or the thermometer in contact with the body. But when we talk about IR thermometer, it is not required physical contact with the human body or physical contact of the surface where you want to measure the temperature. So again, we can understand the importance of this sensor part and the output of sensor. Like I gave the example of mercury thermometer. There it is, the output is given in terms of expansion of mercury. But when I'm talking about digital thermometer, it is giving me the readout, this much degree Fahrenheit or centigrade, whatever you are opting for, right? So that the part where the temperature sensed by the sensor is being converted into readable format, it is converted into useful manner, is done by the transducer. So transducer is a device, it is like the sensor and transducer goes hand to hand, because the sensor will be the basic part, sensing part of the transducer, and transducer will convert the energy, the parameter, into different form. So when we are talking about transducers, so it is a device that converts one form of energy into another form. It can convert maybe temperature into expansion, thermal expansion or expansion of mercury. It can convert temperature into, suppose digital output, it can give you different outputs also. If I'm talking about RTD, as I gave the example of RTD, resistance temperature detector, it usually measures the temperature between 250 degrees centigrade up to 1000 degrees centigrade, or maybe 1100 degrees centigrade. There we can see the output is in the form of change in resistance. If the temperature is changing, the resistance of material is changing, right? So transducers are also classified into different types. There are primary sensor, secondary sensor, then we have primary transducer, secondary transducer, then we have active transducer, passive transducer, we have analog transducer, digital transducer. So this transducer is making use of different technology or different physical properties of the material to give the output. I'll give one example. Like if I'm using resistive sensor, right? So resistive sensor is giving the output in terms of change in the resistance. Like if I'm measuring the pressure, suppose pressure or strain with the help of strain gauge. So basic principle of strain gauge is nothing but it is resistive principle, where the change in resistance occurs with the change in if I'm applying some pressure on the wire, so there will be length of wire will be changed or area of cross section will change, like that. So depending on the working principle also we can classify the transducers. Like it can be resistive principle, it can be inductive principle, it can be capacitive working principle, it can be thermal or electromagnetic, optical or chemical. So these are the different categories of transducers being used. Of course, this transducer will be used with the sensors only. So sensors will give you the sense in the, it will sense the change in parameter, and transducer will convert that parameter into different form. It can be analog output, it can be digital output, it can be in terms of resistance, it can be in terms of capacitance, depending on whatever working principle or whatever type of transducer we are using. Now comes next part, that is actuator. So what happens, this is basically used in process industries, where it is a device that generates a signal or stimulus. So you can see the block diagram given here. The sensor will get the input from real world. So this sensor will have transducer also. So sensor and transducer is like it is, it goes hand to hand, and the sensing part of the transducer is called a sensor. So it will receive the input from real world, or it will sense the change in parameter from the real world, and based on the intelligent feedback system or the processing system, it will give the actuator to make the correction in the system. I'll give one example. Like if I'm taking this, I'm filling a tank, or suppose there is water going in the overhead tank. Now how I am going to sense that when to stop the inlet, right? If I'm not going to stop the inlet water, then it may overflow. There may be wastage of water. So to stop that, I'm going to simply use one sensor, that is float sensor. Everybody will have the float sensor installed in their home. So what happens in this case, it is very small round float type device which is placed inside the tank, and once the level of tank goes down, the motor will automatically turned on and the water level will be increased in the tank. Now once the water level is increased up to a certain value or certain level, then the sensor, the float, will detect how much it has filled. If the sensor has filled to the, if the tank has filled to the maximum value, then this sensor will detect the level, and once it has detected the level is reached to a certain mark, it will give the signal, or it will automatically close the inlet. So this closing of inlet water will be done with the help of actuator. So practical work or the actual work is done by the sensor sensing the level of the water, and once the level of water is achieved, then the actuator will work and it will stop the inlet. Now this example is being used for maybe for toilet flush system. So there also we can see once the flush is done, then the float goes down, the level goes down, and once it goes up, actuator will act and it will stop the inlet water. So that is the whole thing, like how the sensor, transducer and actuator works all together, right? So moving to next, that is yes, transducer, which it transforms energy from one type to another type. So when we are talking about working principle, like I'll give you one example, like capacitive transducer if we are talking, or maybe inductive transducer. So if I'm talking about inductive transducer, we all must have heard about LVDT, linear variable differential transformer. So that uses the principle of inductive or inductive principle to design the, or for working of the transducer or a sensor. So where what happens, if there is change in distance, then there will be change in the mutual induction at the secondary side of the transformer, and depending on that only we are going to find out the the output is in the form of voltage, whereas the input is in the form of displacement, right? So you can just see this is an example of transducer where the input was displacement. If I'm moving there is certain displacement occurring at input side, the output will be in the form of change in inductance, which will give me the output in the form of voltage. It is calibrated in terms of voltage, right? If I am talking about resistive principle, then the output will be in terms of change in resistance. If I am talking about capacitive principle, it will be the change in capacitance. So there are different types of energies, or you can say output we can expect, or different types of sensors we can have. That is one thing. Second thing is that one is based on working principle. Second is primary transducer and secondary transducer. So primary transducer converts one form of energy into another non-electrical form, right? One non-electrical form into another non-electrical form. I'll give one example, like if I'm taking the example of Bourdon tube. Bourdon tube is used to measure the temperature. It is used to measure the pressure. So what happens? It is C-shaped device. This is the tube, and this is the inlet. This is the pressure will be applied from the open end. Now what happens when the pressure is applied? This C shape will try to straighten, right? So now what happens here? this pressure is being converted into displacement. So this side, if I am connecting any sensor, displacement sensor, it will measure the change in pressure into displacement. So this is the example of primary transducer. Now I have given the example of LVDT, that is that is based on inductive principle. Now if I have connected one LVDT from this displacement output, it will give me electrical output. So what is happening? Pressure is being converted into displacement. That is the example of primary transducer. Now this displacement is being converted into electrical form with the help of our LVDT. We can use any kind of displacement transducer which is converting displacement into electrical quantity. That is the example of secondary transducer, whereas Borden tube acts as primary transducer. Now there are different other transducers like analog transducer, digital transducer. So analog transducers or analog sensors are the sensor which is giving the output in the form of analog quantity, whereas in digital sensors, the output will be in the terms of digital output, like digital thermometer, where we are getting the output in the form of digital output. So it will be the example of digital transducer. Then we have active transducer or active sensor and passive sensor. So in active sensor and transducer, what happens? It does not require any external power supply for its application. It does not need any external input, any external voltage for its working. I'll give you the example of this as piezoelectric sensor. If I'm talking about piezoelectric sensor, there if I'm giving the pressure or force is applied on one side of the crystal, piezoelectric crystal, due to its shape change or deformation in the shape, there will be electrical voltage will be generated at the output or at the two sides of the crystal. So that is where we are placing the electrode. So these are the example of active transducer, whereas passive transducer requires external power supply for its application. So this is here we can see there are different energy form which can be used to design the sensor, or which can be used for the application purpose for sensor and transducer designing. So it can be divided into sensors and actuators, which I said sensor is the part which actually senses the change in parameter, whereas actuator are the device or part which impose the action on the system. So this is one part. Then yes, the same thing I have just explained, classification based on physical phenomena, that is mechanical sensor like strain gauge, displacement sensor, that is LVDT, velocity sensor, that is laser vibrometer, accelerometer, tilt meter, viscometer, pressure, etc. So we are using mechanical phenomena to design these kind of sensor, where thermal sensor are, the examples are thermocouple, where we are using the change in temperature will be used as the basic principle of operation of the thermocouple. Then we have optical sensors, that is used in camera or infrared sensor. As I said, in case of very high temperature, when we are using when we are working on very high temperature in suppose steel plant, where the molten steel will have temperature around 22 degrees centigrade, it is not possible to measure the temperature with the help of thermocouple also. So in that case, we are using infrared sensor or infrared pyrometers. That is the term used to measure the temperature above 2000 or 21 degree centigrade. Now classification based on measuring mechanism, that is resistance sensing, capacitance sensing, inductance, piezoelectricity, etc. So these are the different ways by which we are designing the sensor. Then we have materials capable of converting one form of energy into another form. That is like invention of new materials or smart material will permit the design of new types of sensors. So now these are the working principle which based on which we can design the sensor. Now there are different criteria of selecting the sensor or designing the sensor. That is what kind of technology we are going to use, whether it is resistive or maybe inductive, or if we are talking about nanotechnology or any kind of sensor technology we are using. Then what is how the sensor data will be collected. So again, that sensor data collection topology is again very, very important, like how we are going to utilize the data collected by the sensors. Then how we are communicating sensors with the physical world. Then of course power supply is required for any kind of sensor or any kind of device. Then data synchronization, environmental parameters and influences again plays very, very important role in considering any kind of sensor. Of course, remote data analysis is again one of the major parameter nowadays, because everything we are doing, we are trying to control from remote places. So remote data analysis is again one of the factor which we should consider while designing the system. Like I'll take the example of IoT based system. Nowadays IoT based systems are very much being used in all the domains. If I'm designing how this house automation system, where we are going to control the different parameters, maybe bulb, light, geyser, AC, everything being monitored and controlled from remote location. It is possible with the help of IoT based system or IoT based system. Again, IoT based system also, the very basic part, if you study, the sensor comes as the basic part of the IoT based system design. So here we can see if we are going to measure any parameters. So this is physical parameters or physical phenomena will be used to will be measured with the help of sensor system, and then we are going to get the output. So interaction between sensor and the environment surrounding the sensor. So the output will be given with the help of sensor technology or sensor system, and this is the physical phenomena which is where we are going to actually take the measurement. So there are different types of measurement errors also, maybe system error or random error. System error basically it is basically inherent with the system, which which it can be due to maybe design or maybe due to its construction, etc. So then there are random error. It is these errors are uncontrolled errors. We have no control over this random error, and sometimes it is unknown also. Like what is the reason why there is a certain error coming into the system. So system error or systematic error are the error which is due to maybe design due to design of the instrument, or maybe material used in the instrument, or if there is no calibration done, that is also reason of systematic error. Whereas random error are the error which are unknown, which you cannot control. Now comes there are different criteria or different variables which we should look after while designing or taking any sensor into the consideration. So first criteria is accuracy, then we'll discuss resolution, sensitivity, repeatability, precision, etc. So accuracy, if we are talking about, it is the measurement of, or you can say error between the result of measurement and the true value being measured. So it is basically how the measured value is close to true value. If I am giving the input or you can say as 5 volt and the output is coming as 4.9 volt or maybe 4.98 volt, so that is the accuracy, like how accurately it is going to measure. So how closely the output or how closely the measured value to the true value. True value is the input actual value, and measured value is the what value we are going to measure. So that is the definition of accuracy, whereas resolution is how much smallest increment in the input the instrument can measure the instrument can detect. So that is another criteria. If suppose I have taken one sensor and the temperature variation is there and it is not going to take the or suppose if I am going to measure the very low temperature, maybe from maybe 200 degree minus 200 degrees centigrade up to maybe 100 degrees centigrade with the help of RTD, it is not possible to do that. You will not get the accuracy in the result. So in that case, how the sensor is responding to the smallest change in the input, that is the that is called as a resolution. Then comes sensitivity. So sensitivity is defined as the ratio of per unit change in output by per unit change in input. So how like how the output is changing with respect to input, that is nothing but the sensitivity. Suppose if I am measuring the input and the basically in sensitivity we are going to see the slope of input and output. So it should be linear. Right. So again, linearity is one of the very important criteria while designing the sensor or while choosing the sensor. Then we have repeatability or precision. So repeatability is again, it is like if we are measuring the same parameter over and over again, then it should give the same readings every time. If the readings are changing with time, then your instrument does not have good repeatability or it is not precise. So I'll show here, this is the accuracy where this is the measured value and this is the true value. So how this true measured value, how closely it is matching with the true value is your accuracy, whereas resolution is how much minimum change in the input can be detected by the sensor will give you the resolution of the instrument or resolution of the sensor. Then we have accuracy versus precision. So this is the precision without accuracy. So this is my target, and or you can say this is my true value, and every time I'm measuring the getting the measured value, it is coming in this region only. So I can say that my readings are precise, but it is not accurate. It is giving me the repeatability. Repeatedly, it is giving me the same result, but it is not accurate. It is not close to this. Here I can see the readings scattered throughout this accuracy region. So here I can say it is the accuracy is there for this instrument, but it does not have any precision. Whereas here you can see the graph given here, the diagram given here shows the instrument is accurate as well as precise. So these are the three diagram which is showing precision without accuracy, accuracy without precision, and it is showing precision and accuracy both in this diagram. There are few more criteria which we have to see, like dynamic range. So range is again there are static range and dynamic range. So it is basically measuring the range, like minimum value and what is the maximum value the instrument can detect, the instrument can measure. That is the range of the instrument. Again, when I was discussing sensitivity, I spoke about linearity also. Again, the deviation of the output from best fit straight linear region for the given range of sensor is nothing but linearity. So here basically your output should follow the input linearly. So then only I can say that the output or the instrument is linear or instrument has the linearity property. So again, the transfer function, or we can say it as frequency response also. So it gives the relationship between physical input signal and the electrical output signal. So as we know, transfer function is nothing but output by input. So it is giving me the response of the instrument or response of the sensor. This is again one of the criteria of selecting the instrument. Then we have bandwidth. So bandwidth is nothing but how much, what is the range of frequency which can the instrument can be sensitive for. Like it is the frequency range between the lower and upper cutoff frequency within which the sensor transfer function is the constant. It has constant gain or it is linear. So basically bandwidth will be or you can say the bandwidth of the sensor is one of the criteria which we should keep in the mind. Again, noise is unwanted criteria or unwanted part which is not required in the sensor. But again, random fluctuation in the value of input that causes random fluctuation in the output is nothing but the noise. This is unwanted parameter of the sensor. Then different attributes are there, that is operating principle, like different kind of operating principles can be used: electro-optic, magneto-optic, electromagnetic, piezoelectric, active, passive, then ultraviolet, etc. These are the different types of operating principle we can use for sensors. Then there are different dimensions. What is the size of physical size of the sensor, what kind of data format we require, whether you want analog format or digital format. These are the different ways we are going to design the sensor or select the sensor based on these things. Then again, intelligence is one of the parameter, that is capabilities of on-board data processing and decision making. Then active versus passive. Active is self-generative, whereas passive requires external input, external supply for its functioning. Then physical contact, that is the way sensors observe the disturbance in the environment, the way it is detecting the change in the parameters in its surrounding. Then environmental durability, will the sensor robust enough for its operation conditions. So again, that is one of the very important criteria which we should look after. Then as I said, analog sensor, digital sensors, we will have the output in the form of analog quantity, and digital sensor will have output in the form of digital quantity. We have different types of sensors. Suppose I'll give you one example. I have taken only one example of strain gauge, which can be based on different principles. Like if I'm talking about foil strain gauge, so it can be based on strain gauge can be based on resistive principle, it can be based on fiber optic principle, etc. So the advantage of this, it is not expensive, it can be used widely, and it, again, it is not suitable for long distance application. So these are the properties, or you can say advantage and disadvantage of foil based strain gauge. Again, vibration wire strain gauge, it determines strain from frequency of AC signal, but the disadvantage will be it is bulky. Again, if we are talking about fiber optic based gauge, it is immune to electromagnetic and electrostatic interference. The advantage will be again the compact size, but disadvantage will be high cost and it is fragile. We have different types of sensors. Once we have done the classifications based on the working principle types, like analog, digital, primary, secondary, active, passive, like that, we can design the sensor based on the physical parameters, like as I said, temperature sensor. So temperature sensor also can be of different types. It can be categorized based on low range temperature sensor, medium range, high range, and very high range. So different types of sensors can be designed. Then infrared sensors are there. We have light sensor. So it is you can see it is also known as photosensors. Light sensors are one of the important sensors. So again, we can see everywhere, we are using here in case of LDR. So the property of LDR is that the resistance will be inversely proportional to intensity of ambient light. So we are using this property to design the light sensor. Touch sensor, we all are using, like mobile phone, tablet, laptops, everywhere we are using the touch sensor. Then moving to next, that is smoke and gas sensor. We have alcohol sensor. So again, smoke and gas sensor will be used to detect the smoke, like it is used for safety purpose in buildings, in institutions, malls, everywhere we are using this kind of smoke sensors, which is helpful in security measure, taking the security measure. Then we have alcohol sensor. Here also we are using the breath analyzer devices to determine whether the person is drunk or not. So that is again very useful for law enforcement and to stop the drunk and drive accidents and like that. It is useful sensor which is being used nowadays. Now next is humidity sensor. It is measuring the how much humidity is present in any any device or any suppose if I am taking the example of soil. So nowadays soil monitoring is also one of the important criteria for farmers or advanced level research is done for while we are going to while we are going to build any do some kind of construction. So soil monitoring, again we are going to measure the humidity level in the soil, or humidity is also required in terms of like atmospheric humidity. So there also we are using the humidity sensor to give the weather forecasting or weather monitoring is required. So now the next is tilt sensor. So it is used to detect the inclination or orientation of the device. So next, that is uses of sensor. It is used in daily everyday object. So starting from our household thing, like where we are using maybe touch sensor in mobile phone, tablet, or maybe in microwave. In my washing machine is also we are using sensors. Again, when we take the example of TV remote, also make use of sensor to make the change in the channels or whatever it is. So you can see here starting from like elevators, lamps to dim the brighten the light, etc. We are using the sensors. So there are innumerable application of this technology. Without this, it is not possible to live our life nowadays. The application includes cars, machines, aerospace, medicine, manufacturing, and robotics. I'll share a few pictures like sensor tabs. So here we are using infrared sensor and used, you can see here, automatic sensor. When we are placing the hand in front of tap, it is automatically the water is coming out from this. So there we are making use of sensor. Again, nowadays if you are going to any shopping mall, you are before entering only, if you are in the proximity, the door will be open. So that is also being used. That is also one type of sensor we are using there. So here you can see automatic sensor is easy to install and it is simple to use as well. Next example is elevator, automatic stairs, which is seen in all the shopping malls. So it will start and stop automatically when you are coming in the proximity. So what happens, the automatic stair will be stopped, but as soon as you go towards the stairs, it will start moving. So that is again used for energy saving, and it will be very useful for the person, which it is very convenient mode to move from one place to other place, from one floor to other floor. So this is automatic stairs. Again, here also we are making use of the sensor. Then this is another infrared sensors we are using in like touch screen we are using. Then in smart devices we are using infrared sensors. Again, hotels are also using infrared keys nowadays. So the card will be placed inside the or it will be just touched near to this device, and the door will be open. So these are the different areas where we are using infrared sensors. Then again, photoelectric sensor are being installed on highways or all the street lights nowadays by government. So what happens here, this is solar based or you can say photoelectric sensors are there, which will automatically turn on when there is when there is no light, or during night time it will be on, and during morning time it will be automatically switched off. So that is again, so you can see these are used in the street lights and automatic stairs. So it automatically turns on and off as sunrise or sunsets. So these are the again one of the very widely used application of sensors we can see near to our places. Then we have touch sensors. Again, as I said, when we are using lift, so there we are using touch sensors. Again, when we are using barcode sensors, so there are different types of sensors we are seeing in our daily life. Apart from this, we can see if we are going to shopping mall, there also we can see there are different sensors. As soon as you enter, there is automatically door will be opened, or if you are using elevator, the automatic stairs, that is also based on sensors only. Once you go inside, then there also we can make use of one screen where you can find the whatever you are requiring. If you want some dress or you want something, there you can search whether it is available in the store or not. Again, while doing the billing, there also we are making use of sensors. So everywhere we are making use of sensors nowadays. Now moving to next, that is advantages of sensors. So again, sensors, it avoids a lot of wiring. So it is like mostly it is non-contact type of sensor only we are using nowadays. It can accommodate new devices at any time. It is flexible to go through physical partitions. Also, the advantage will include that it can be accessed through a centralized monitor. As I gave the example of home automation system. So if you have connected everything with IoT devices, or if you have connected to remote control devices. So if you are sitting or you are coming back to your home from the office or from airport or anywhere, you have the facility to switch on your geyser or maybe AC or light before reaching home, so that it will be pleasant for you to enter or to stay. So then again, sensors such as PIR sensors detectors are relatively cheap if using wired version. And we have right. So next, the conclusion part. So sensors are most useful and efficient technology in almost all the domain, starting from our daily use to our mobile phone or laptop study related, or nowadays with the help of wherever we are going, everywhere we see different types of sensors being used in our day-to-day life. So engineers must keep in mind while designing the sensors, that is, the materials should be easily available. It should be of low cost, and the design of the sensor should be simple. Again, the cost, it should be cost effective. There should be low power consumption for any instrument or for any sensor. If I'm talking about instrument means every instrument will have some kind of sensing device, right? So that is why I said low power consumption of any instrument. It is basically the sensor, also one of the part of the instrument. So it should be reliable. Again, the size is also a very, very important part of the sensor designing. So that's all from my side. So if there is any query, I would like to answer.
Participants, if you have any queries, please unmute yourself. You can answer. You can ask.
It was very nice presentation in very simple language and very understandable. Everyone can understand, like
Thank
how
you.
street light will on and off as per sun. So it was really very good. Yeah. So it was a very nice session. Yes. So anybody is having any doubt or any question? I think it was self-explanatory. I think so.
It was very basic, ma'am. Actually,
Yes.
If I go to one particular field, like my field is magneto-optic sensor design, so it would have been, like for everyone,
Narrow
it's
down.
not.
Yes, I understand.
I kept it to very general so that it is
Yes,
easy for everyone to correlate. That was the
yes,
main.
yes, yes. It is required actually. All sort of flowers are required in the garden.
Yes, ma'am.
So it was required. So I am really very thankful to you. So I think Jara sir, in chat box any question is there? In chat box?
No, no
If
questions.
not, no question. Okay. If
Yeah.
not, then we will request them to switch on the camera if possible. We'll take a snapshot. My photo I cannot see. I don't know, something
Oh,
went
yeah,
wrong. But
yeah, visible. Yeah, visible.
but you can see.
Yes, ma'am. It is visible for us.
Okay, okay. Okay, so few people will on the camera. Because first few days speaker we have not taken the photo. After that I come to know, so we are taking. This Usha Rani and Supriya ma'am and all regular, their photo is coming. Thanks. Valedictory time now. Please introduce yourself. Okay, all of you participant. We are very happy. We are very happy to know about you, from where you are. Yes. Sarita ma'am, if possible, at the time of valedictory function, you also join.
Sure, ma'am. Sure, ma'am. Thank you so much for giving me this opportunity.
Thank you. Thank you for accepting.
Thank you,
Last
ma'am.
day, I will tell all of you
Yes, ma'am.
about the valedictory function. Last day means 27th, because tomorrow election is here. So tomorrow our college is holiday. Okay, tomorrow we
Yes.
will go for the voting. Saturday morning time, speaker is from the UK. Okay, he's a research fellow there. Okay, so you can interact with them. You can ask how to get the opportunity to do the PDF, or fellow, okay, research associate, research fellow in London. So all those type of information, because he is very helpful. Okay, Deepak is
Deepak.
giving talk. Yes, yes. So currently he is in US. Sorry, UK.
UK.
So this type of opportunity we should grab it. Okay. Jara sir, you have taken few snapshot.
Yeah, ma'am. Taken.
We should have a database actually. Whenever we are doing any FDP, or we are writing the proposal for FDP, if from the participant, if any good speaker is there, we can take this, we can take their name. So we will, what actually I am planning, Jara sir, if possible, we will tell them in the group. They all are in the group. They can write in the group from where they are and what is their specialization. Okay, so that if anyone want to apply for the now Atal FDP came, AICT, so all are writing the proposal. I hope everybody. Okay, it is there now, AICT, Atal FDP. So you want a speaker, so you can get from here itself, from the.
Yes,
So
ma'am.
this is the opportunity. Not only we are learning the new technology, but we are getting the platform to network with others. Okay, Jarraj, you write like that, so that we will have the database of all the speakers also in future. Okay. Okay. Thank you, Sarita ma'am.
Thank you so much, ma'am.
Thank you. So we'll meet by 2 afternoon, 2 o'clock.
ಬೆಳಗ್ಗೆ ಆಗಲ್ಲ ಅದು ಅಂದ್ರೆ ಆಗದೆ ಅದು. ಅಂಗಡಿಗಳು ಇದ್ದಾರೆ. ನಾವು ನಮ್ಮ ಕೈ ಮೇಲೆ ಬೆಲೆ ಕೊಡೋದು. ತೆಗೆದಿಡಬೇಕು. ಎಲ್ಲ ಏರಿ ಇದು ನಮ್ಮ ಕೈಲಿ ಅದು ಹಿಂಗೆಲ್ಲ ಎಷ್ಟು ಬಸ್ಗಳು ಸಿಕ್ಕಿಲ್ಲ. ಸರಿ ಹೇಳು ವ್ಯೂಗೆ. ಪ್ರೈವೇಟ್ ಯಾವ್ದು ಬರಲಿಲ್ವಾ? ಇದರ ಅದೇ ನಾನು ಅಂಗಡಿ ಬರ್ತೀನಿ. ಆಮೇಲೆ ಪಿಕಪ್ ಮಾಡ್ತೀನಿ ಅಷ್ಟೇ. ನನಗೆ ಹೌದು. ಇಲ್ಲಾಕಿನೇನೆ ನನಗೆ ಹಂಗೆ ಅವಳು ಗಾಡಿ ತಗೊಂಡು ಕಾಲ್ ಮಾಡ್ದ ಏನೋ ತಲೆ ಅಷ್ಟೇ ತಿಂತಿರೋ ಅಂತ ಎಲೆಕ್ಷನ್ ಇದಕ್ಕೆ ವೋಟಿಂಗ್ ಅಲ್ಲೋ ನಾನು ಹೇಳಕ್ ಬಂದಿದ್ದಂದ್ರೆ ಕನ್ನಡದಲ್ಲಿ ಅಂದ್ರೆ ಮರ್ಯಾದೆ ತಿಳ್ಕೊತಾರೆ ಅಂದ್ರೆ ಇವಾಗ ಬಾಯಿ ಆದ್ರೂ ಫಸ್ಟ್ ಇವಾಗ ನನ್ ಬಗ್ಗೆ ಏನು ಕಾಳಜಿ ಮಾಡ್ತಿಲ್ಲ ಇಲ್ಲ ಇದು ಅಡ್ವಾಂಟೇಜ್ ಆಗುತ್ತೆ ಒಂದೇ ನನಗೆ ಯಾಕೆ ನನಗೆ ನೋಡಿ ಇದರಲ್ಲಿ ಅದು ಆಗಲ್ಲ ಅಂತ ಗೊತ್ತಿರೋದು. ಆದ್ರೂ ಹಿಂದೆ ಮತ್ತೆ ನಾನೇ ಅವರೇ ಆಡ್ತಾರೆ. ಅದನ್ನು ಎಲ್ಲೂ ಅದರಲ್ಲೂ ನಮ್ಮ ಹಾಗೆ ಅನ್ಸುತ್ತೆ. ಆಗಲ್ಲ ಅಂತ ಗೊತ್ತು. ಆಗಲ್ಲ ಅಂತ ಅಂತ ಪರಿಸ್ಥಿತಿ ಕಳ್ಕೊಂಡ್ಬಿಟ್ಟಿರ್ತಾರೆ ಅಂದ್ರೆ ಆದ್ರೂ ಫೀಲ್ ದಟ್ ನಾಟ್ ಇಂಥ ಒಣ ಪ್ರತಿಷ್ಠೆ ಅವ್ರಿಗೆ ಏನಕ್ಕೆ ಇದೆಲ್ಲ ಸ್ವಲ್ಪ ನಾನು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಹೇಗೆ ಅದಕ್ಕೆ ಹಾಕ್ಕೊಡ್ಬೇಕು. ಅವ್ನು ಬರ್ತಾನೆ ಹೇಳೋದು ಮೇಲ್ದಸ್ಕೊಂಡಿಗೆ ನೋಡ್ಕೊಂಡು ಬರ್ತೀನಿ ಅವ್ರಿಗೆ ಅದರಿಂದ ಬರೆಯೋದು